Good morning. This question is from Resnick and Halliday. And as you can see, the topic is center of mass. In this question, two bodies have undergone an elastic collision. Very important keyword to notice. And the graph is position versus time for both the bodies. And you have to answer some questions based on the graph. Okay, tricky question, but if you analyze and think about it, it's not that hard. So let's discuss this question now. So if you can notice, the position versus time graph gives you velocity, right, or so to say speed. And if you notice, the point at which both the bodies are meeting, colliding, probably is this, because it shows common position. So they collided here, and we have to find out. First question is, were both the bodies initially moving or one of them was stationary? Now, although the velocity of both the bodies is given, but I will not solve this problem in a conventional manner. What struck me in this problem was the part number, which line segment that corresponds to the motion of the center of mass. This was very striking when I noticed this question. The line segment, now if you know, the center of mass cannot change if the collision is elastic. For you to change center of mass, you need to change the momentum of the system. In this case, the momentum of the system undergoes no change, which means the center of mass will not change. The position of center of mass cannot change because the collision is elastic. So if you notice, the line number 1 and line number 6, they represent, on the left hand side, this is before the collision and this is after the collision, right? So the position has not changed. So 6 is after the collision and 1 is before the collision, right? I hope the concept is clear in your mind. Now let's think in terms of this other parts of the question. I think the first one is pretty simple. Were both bodies initially moving? Yes, they were, because if you notice, the only two lines which are left to interpret are line number 2 and 3, and both have a slope. That means both are in motion. This is the point of collision. So both of them were in motion. So the answer is both were initially moving, right? Now comes the tricky part. Okay. Now the question is the mass of the body that was moving faster. So you can notice the slope of 3, this particular slope is quite large, right? So this is the slope is, so this body is moving faster than the body with this velocity. So let's call it, for example, m1, m faster, sorry, v faster, and this is v slower. Okay. Now the question is, before and after the collision, moving faster before a collision, greater than, less than, or equal to. Now let's analyze the situation number 1. See, the question is not exactly that straightforward. For this, you need to know something like what exactly is happening by way of collision and how do you link this to the concept of momentum conservation. So let me draw this situation. These are the two circles I have. Okay, they represent, okay, equal. So let me redraw this, and this is my. So both are of, assume they are of equal mass, and I'll tell you why. They are of equal mass. So in your mind you must have a chart of lot of elastic collisions. Elastic collisions. Okay, one of the very special case which is very important is the case when the two masses are equal. This is one situation. The second situation is when both the masses had certain velocity, maybe u1 and u2, which could be u slow or u fast. Within this, you have two situations. One mass was stationary. When I saw this question, what came to my mind was this word, okay? And so the emphasis is mass, but they're saying the mass is equal, less than, or greater than, right? So I'm just considering in my mind that they are focusing on the special case of equal masses, and therefore I just thought when I looked at the slope of the lines, the slope of this particular body continues here, and the slope of this particular body also continues here. And here lies the trick in understanding this. Once two bodies of mass m, they collide head on. Okay, so this is with velocity u, this is with velocity v. If they collide head on, after the collision, this is what happens, and this is where the trick resides. So you should be quickly able to understand the emphasis of the question. I could have solved this for all the situations. So this is my ball number one, and this is my, now what is going to happen is the head-on collision has happened. Something will happen. This particular mass will be v now, and this will be u, which means if there is a collision of the bodies of equal masses and they collide elastically, interchange of velocity happens. Interchange means they interchange the velocity. Okay, the interchange. So if this was 2 meter per second hypothetically of mass 1, and this was 3 meter per second of mass 2, now it will change. This body, the second mass, will now be 2 meter per second, and the first mass will be 3 meter per second. So did you see the interchange of the velocity which has happened? Okay, let's go back to the graph and see whether this kind of interchange happened or not. So to me it appears, and I'll just remove this work which we have done, and let's analyze it with respect to what's happening here. We have already identified 1 and 6 to be the 1 and 6 are the before collision and after collision center of mass location. So which means this body, the 2, it was going, it probably interchanged the velocity and it acquired the velocity of the second body. So this is body number A and this is body number B. So the velocity of A got acquired by B. So after the collision, the velocity of A has gone to B, interchange, and the velocity of B, which is this, the maybe UB, has gone to A. Okay. So this is an interchange, right? So whenever you're given these questions, instead of focusing on trying to attempt all permutation and combination of greater than, less than, the first thing that struck me at least was, because of my practice, is that this seemingly is a situation of equal masses. Read about elastic collision for equal masses, right? And read one more situation where one of the body is stationary and the other body is in motion. In those cases, the body which is stationary acquires the mass of the other body, and the body which was in motion becomes stationary. It's another example of interchange of velocity, but one body is stationary. I hope you liked this immensely. If you did, please put your comments and wait for my next video. Thank you very much. Right? Equal masses have special emphasis in center of mass and momentum questions.